I'm going to do these 3 math workshop problems. If you don't have this math workshop, I passed it out 2 Fridays ago. We decided that date was the what?
19.
So it was before this. So it's 19 minutes and 12. The 12th. When we finish, 5 get a point, 4 get a point, 2 point, 6 point, 1 point. When we finish, yes. When we finish and we start recording, I'll actually show you the test. I just refuse to record the test on the screen. That seems a little bit ridiculous of me.
No, I think it's fine.
Yeah, I know. Some of the problems from our math workshop, specifically the ones we're going over today, are going to be on the test. There's going to be similar ones to 4, 5, and 6 on the test. That's why I picked 4, 5, and 6 to start today. Okay. I would love some help with number 4.
6.
I would love some help with number 4. Table. See, Seth said something too. I really wish someone would fix something first before we start worrying about the 3. There's something inside we should fix first. Yeah, Mia said it first, so her group gets the point. So let's move b to the negative 9th to the bottom. Okay. What should I do from here? 6 goes to 9, he says. But when we raise a power to a power, don't we multiply the exponents? Okay. So I'm going to have 5 to the 3rd, which is what number? What is 5 raised to the 3rd power? I need to know that number. Who said that? It was Eduardo. Okay. Thank you, Eduardo. So it should be a 125. And then it's a to the what number and b to the what number? Are you raising a power? Did you multiply the exponents? So it's a to the what number? Okay, and then b to the...
27.
Okay, 2 get the point. So our final answer should be 125, a to the 18th, b to the 27. I know it's a Monday. I know you're excited. I'm with you. When you raise the power, you've got to multiply your exponents. If you've forgotten your rules of exponents, Lord, you need to look over those tonight, because I'm telling you, like, the first 5 test questions are just straight up rules of exponents. Okay, number 5, we're dividing. When we divide, what do we do with the exponents?
Subtract.
Subtract. I heard it from 1 and 6. You can both get a point.
However, here's the problem. Both of the C's are up and all of these are on the bottom.
Yeah, so we normally would subtract, and that's why I'm giving them a point. But instead, they've tricked us on this one. So negative 21 divided by 3 is negative 7. But it's c to the, they're both in the top, so I actually add them. So it's c to the 9th. And then d to the, yes. Okay, so Arturo gets the point. He's paying more attention than most of us. The c's were both in the numerator, so he added them. He added their exponents, 3 plus 6, and got 9. The d's were both in the denominator, so he added them, 10 plus 1, he got 11. Negative 21 divided by 3 is negative 7. I just went ahead and simplified it. Okay, next we have number 6, and that's the easiest one of the day. We're multiplying, so we literally just add our exponents, so it's q to the... If you said 9th, I would like, that makes me sad. There's an understood 1, 3 plus 6 plus 1 is 10. Every group can have a point, but you and I both know that I heard a 9 from someone. Okay. Let's look back over things. Okay, so I've got my notes packet. And I want to look back over that study guide, which I posted the key to this yesterday. So, the first 5 questions look very similar to our math workshop. Because the first 5 questions are all dealing with exponents. There shouldn't be any questions about those. That should be something you're familiar with. Okay, and then 6 through 11, we decided we're a pain in the rear. Because they wanted you to not only do the math, but then they wanted you to say degree, leading coefficient, and number of terms. Thankfully, on the test, those are 2 different questions. So they're 2, you don't have to do both. There's questions on degree, leading coefficient, number of terms, and there are questions on can you just combine like terms. So they're in 2 different worlds. So 6 through 11 is actually going to be a little easier on the test than what you see here on the paper. 12 through 19 are where life gets a little difficult and takes a little time. You have to pick long division or synthetic division. And then I don't know how you could possibly mess up 20 through 23, but we'll talk about that in just a second. Okay, what I want to do is the last 3 on the back, I want them to do them together. So let's talk about where we left off. On Friday, yes. On Friday we were talking about how I could recognize, or how I could graph this function easily just by looking at the equation. And we're going to spend a lot more time on that later this week. For now, we just need to know some basic stuff about how to graph it. There were some key things we discussed on Friday, and once we go over these 3, I feel like you'll have those 3 key things down. One of them was zeros. How do we decide where the zeros are for this function? Okay, so what are my zeros for this problem? Was that you, Kelsey? Then you can have your point. Are there any questions about how Kelsey got those zeros? Okay, so I know at -2, at 1, and at +4, my graph is going to cross the x-axis. That's what a 0 is. It means where my graph crosses that x-axis. When I grade Arturo's test, he doesn't actually have to graph tomorrow, but he will have to list the zeros. And obviously for his future self, he needs to understand what those zeros mean. Okay, there's another thing we can also guess just by looking at it, and we do not have to work it out. What is the degree of this polynomial? Yes, 3 is the point. I see a 1, and a 2, 2, 3, 4, so x to the 4th is as high as it gets. And all that really helps us know is that the higher the degree, the more loopies and stuff might go on in the graph. So it's not going to be just your normal parabola. No, that was degree 2. So degree 4 is going to look a little more complicated than that. That's all we really need to know for the test tomorrow. We'll get more specific about what we should think about with degree 4 later this week. Okay, so I know the zeros, I know the degree. There was an M word we discussed on Friday. There are multiple zeros, but there was another word. Yes, 4. Get your point. And it was multiplicity. Do any of these zeros have a multiplicity that's higher than 1? Yes. So since we see this squared part, we actually know 4 has a multiplicity of 2. And all that means when we're graphing is that something special is going to happen at 4. It's not just going to cross through 4. It's probably going to have a hump or something at 4. So if we're guessing how to graph this, there's one teeny tiny other thing we might want to do before we straight up guess our graph. And that has to deal with the leading coefficient. And I don't even need a number. I just need to know, is the leading coefficient going to be something positive or is it something negative? So look at our problem at the very front. Do you think you assume at the end of the day it's going to be all positive, a positive thing or a negative thing? I assume it's going to be positive because on number 2 I assume negative. And number 3 I assume positive. I'm seriously just looking at the very front. Is it a plus sign or a minus sign? At the very front of our problem is a plus sign, so I'm assuming it's a plus sign. Now you and I know we've discussed plus signs mean our graph is happy, so we're probably starting up here. But again, that's not a guarantee. I could still check all this with my graphing calculator. No one's taking that away from me. I think my graph will go through down here, somehow loop and come back up. I mean, but that makes sense because it needs to cross both those zeros. And then somehow it's going to come down and have a double loop there. Now again, on the test tomorrow, Seth doesn't actually have to sketch this purple graph. On the test tomorrow, he literally has to talk about zeros, degrees, multiplicity. But the reason he's got to understand zeros, degrees, multiplicity is because it helps us eventually get to this graph. For instance, that multiplicity of 2 is why there is a special hump at the point 4. No one else has a hump at that point. See, it just crosses through 1. It just crosses through negative 2. It actually has the hump at 4. Okay, if you're good, are there any questions about that? Okay, if you're good, let's go to number 2. I need to know this. Well, number 2 is not as easy. Why is number 2 not as easy?
Because that's only 3 terms.
There are only 3 terms. Can you instantly spot the zeros with that one? No, it's not. It's in standard form. It's not in, what was the other form, vertex? No, it said it in our notes, so I'm going to be in a blind. If you get to it first, you'll get your point. It was in the notes. Thank you for its point. Factored form. It's not in factored form. Okay, so instead we need to factor first, which is kind of why we've been practicing factoring. Is there a GCF in this problem? Did you say that? Eduardo, get your point. If we factor out a negative x, we're left with x squared plus 7x plus 10. Factoring out that negative, and everybody else got to become positive. Now, I know you have yours done, so I'm not going to let you answer the next one, Eduardo. Okay, this is an easy factor. I need something that adds to 7 and multiplies to 10. So x plus 1, x plus 1. 5 and 2. X plus 2, x plus 5. 5 plus 2 is 7. 5 times 2 is 10. That's perfect. And the reason we did all this is because now I can actually physically list those zeros. What are my zeros? So it's 0, negative 2, negative 5. 3 I heard you first. You can have your point. I'm mostly impressed that I heard everyone who said something out loud mention that 0. Don't forget this one is the 0. 0, negative 2, negative 5. So I know when I'm sketching my graph, I'm going to cross at 0, negative 2, negative 5. Do any of my zeros have a multiplicity higher than 1? No. So there's no multiplicity for us to worry about, which means we're not going to have any special humps. We're literally just going to cross through these 3 points. We're not going to have a cool little hump at a point. And the last thing we could ask ourselves about is the degree. What is the degree of this polynomial? Yes. Look at the very beginning. They told you at the very beginning. The highest exponent was a 3, so the degree is 3. So it was nice when it was in this form to tell you the degree and stuff about that leading coefficient, because we know that leading coefficient is a negative 1. So we know if we're questioning this positive negative life, we're negative. So we could have done the 2 parts in gray before we factored. We had to factor in order to figure out the zeros. Okay, but we can graph from here. So it's a negative in front, a negative leading coefficient. I know you don't know this. I swear that's Wednesday's problem. A normal positive cubic graph looks like a snake. So since it's negative, it's going to look like the backward snake. So we're going to say maybe it goes like snake through this, snake through that, snake through this, down. Now, should you have automatically known that? Heck no. That's what later this week's problem is. Am I taking your graphing calculator away from you? No, I'm not. So could you have figured this out regardless of all the words I'm using? Absolutely. If you were trying to just straight up graph it and figure out the zeros from graphing, you can still set your bounds and make your calculator tell you the zeros. Everything we do with parabolas, zooming in and second calculate, all those buttons still work. They didn't die. So they could still help you reach the answer in life. Are there any questions about number 2? Our last one of the day is number 3, and when I first saw it, I stopped. And I was like, I don't know how to do that, but I do. I do. First of all, let's list the degree and the leading coefficient, because we already know those. And the leading coefficient is a positive 1, so I'm going to say it's positive, yes. 1 gets the point. Okay, but I need to factor this, because I need to know where my zeros are. How do we factor this? How many terms are there? Grouping, because there are 4 terms. I don't know why that didn't come to me yesterday, Kelsey. I started it for way too long. You can have your point. If I group, the first group I pull out an x, I have an x plus 7. The second group I pull out a negative 1, and I'm left with an x plus 7. So I'm going to put x plus 7 and x minus 1. I pulled out, you're cool with pulling out the x, and you're cool with the fact that I pulled out a negative 1. In fact, if you need to write that one today, I understand. I'm sorry. So where does that mean my zeros occur? 6 get another point. So my zeros are at 1 and negative 7. What kind of polynomial is this? What's its degree? So what kind of graph should I have? Cube would be a 3. It's just the U, which had a proper name, and it was called, what was this called? It had a name. What was this called? Parabola. My gosh, it's okay. So meanwhile, I know it's going to cross and look like this, and I know it is a happy face because table 1 told me it was positive. And we're done with that. Are there any questions about this? Say it again, ma'am. The degree is 2. That's why I knew it was a problem. Okay, so